So, in today's lecture, we're going to discuss the four characteristics of an object-oriented programming language, using C# as an example. So, we've seen actually examples of all these characteristics. Some people call them pillars: encapsulation, inheritance, polymorphism, and abstraction. So, encapsulation, you have private data, public methods, but member visibility is the class designer's choice. So you're encapsulated within a class, whether or not you want to let outside code have access to data or to methods is up to the class designer's choice. Encapsulation. Inheritance, from general to specific. In inheritance, a derived class inherits the properties and methods of its base class and extends them. In extending those characteristics, it becomes a more specific type. All C# classes inherit from object, gaining, among others, the toString method, the equals method. In object, those methods are very general, but reasonable. We override them to get custom behavior for your more specific class. Polymorphism, many forms. An object handle can be declared as a more general type, but it will behave as the type that is actually instantiated. In this case, instantiated means an object instance created with the new keyword. So, for example, object O. The O is declared as a general object, the most general type you can possibly declare it as. But then we instantiate, let's say, a new student class. When we do O.toString, it doesn't behave like object's toString, just let's say, producing the name of the class that it is. It actually runs the toString method if you've overridden it in student. So it behaves like student's toString method. Abstraction, the ability to express an idea without knowing the exact implementation. If you remember, object-oriented at the top is general. So at the top of the hierarchy, you're thinking generally about a problem. As you get more and more specific, you're thinking about more and more specific behaviors. So we think in abstractions all the time. For example, an animal. An animal eats, it moves, it breathes oxygen. But these are abstract ideas. There's no critter that is just an animal. So animal is an abstract notion. When we start thinking about specific animals, specific instances, then we know more about the specific behavior. Is it a carnivore? It eats meat. How does it move? Does it move quickly? Does it move slowly? Does it run? Does it swim? It breathes oxygen. How does it breathe? Does it have lungs or gills? All of these things we can generally describe as behaviors of an animal, but to get specific behavior, we study specific animals. In code, you would model generally object, and then as you go further and further down the hierarchy, you get more and more specific behaviors. So support for an abstraction is object-oriented languages' support for this method of reasoning. Here's an abstract example that we went through in the previous lectures. I-comparable. You know when you're doing sorting that the sort routine needs to know less than, greater than, equal to. But it's up to the specific class to decide how that is done. So you generally have the idea that sorting needs to know those three characteristics: less than, equal to, greater than. But we don't know the implementation details of that until we get to the actual class itself and the business needs of that class to put itself in sorted order. And we can see many cases where you'd want to sort in different ways. For example, of an employee class, you might want to sort on employee ID, employee last name, on salary, on hire date. There's many characteristics that you could end up in sorted order. So the specific details about how sort routine works in terms of comparison are left to the class itself, whereas the sort routine just knows how to put objects in a sorted order. So sorting, I-comparable, is support for abstraction. So let's review the shape example that we went through in the previous lecture. The circle inherits from drawable. Therefore, we can say it is a drawable. The rectangle inherited from the drawable and the printable, therefore is a drawable, and rectangle is a printable. In the next example, we're going to modify the shape example to be this. Instead of rectangle inheriting directly from drawable or printable, or circle, and same thing, we're going to have a shape. The shape is going to be an abstract class. It's going to inherit from drawable and printable, and then rectangle will inherit from shape, and circle will also inherit from shape. So rectangle is a shape, circle is a shape, but you can also say that circle is a drawable and that circle is a printable. Same thing for rectangle. So we'll take a look at the example, and we'll review these characteristics in that example: encapsulation, inheritance, polymorphism, and abstraction. Please join me in the next lecture.